Our next example problem is about baseball. So we'll give you a little drawing and get you set up on this one. You can see there are a lot of similarities to these problems we're doing. It seems like we're using the same formula quite a few times. So let's look at it. Each side of a square baseball diamond is 90 feet long. If a ball is hit down the third baseline at a speed of 100 feet per second, how fast is the distance from the ball to first base changing when the ball is halfway to third base? Let's take a look. So I've drawn a little diamond off on the right hand side. So first base is there on the right, and our third base that's just over here on the left, and home, where the batter would be down there at the bottom. Second base, of course, is up top. Okay, these are neither here nor there, but just want everybody to be at the same spot. So let's read again. Each side of a square baseball diamond is 90 feet. So I have 90s written in for all of them. Now, if a ball is hit down the third base line, I've drawn it in red, at a speed of 100 feet per second. We're going to need to define variables in a second. We'll get back to that. How fast is the distance from the ball in red, to first base changing when the ball is halfway down? Well, I think what we should probably do is connect. Let's connect these. Wow, that's not even close to a straight line. Maybe if I just keep drawing it over and over, it'll get straighter. Yeah, that got worse. Okay, but what we have here is a right triangle. So we merely need to just label these so we can figure out what's going on. It's another one of those same problems, just with more words. So it looks like, do you mind if I'm just going to label them? I'm just going to call them stuff. How about X, Y, and Z? Cool? So let's set up our little game. I'm going a little out of order this time. I'm not finding the rates first. We're just going to set it up. X squared plus Y squared is equal to Z squared. There's our formula. Now our question is, we want to know what's dz dt. What's the change in Z with respect to time? So that'll change because our X values, as the ball is moving down the line, our X is changing. So we know that changes. We know the Z changes. But from home to first, that's always 90. So we can actually change our formula up a little bit and call it X squared plus 90 squared is equal to Z squared. Now let's go through and take a derivative. So we get 2x dx dt. Man, this must seem very familiar to y'all already. Is plus absolutely nothing is equal to 2 times z times dz dt. Hey, that's what we're looking for, right? That dz dt. We want to know what's that? What's our dz dt? How's that z changing with respect to time? All right. Well, we can now go back, and we just need to go start plugging in our values. So we have 2. Would you mind? I didn't do it in the last example. Why don't we just do this? Get rid of those 2's. You know what I mean? And I'm actually just going to go through and solve for dz dt. You see the z value that's over on the right? Let's divide that over, bring it over to the other side so we can see it. So we still have this x times our dx dt, but we're going to take the z from over here. We're going to divide that out, and we end up with x over z times dx dt. And we're looking for dz dt. So let's see if we can't just plug in and see what's left. What do we need to get? So we need to get our x value, we need to get our z value, and we need to write in our dx dt, but we're already given dx dt. I'm pretty sure of that. Dx dt, what's that? Oh, that was the ball traveling down the line, right? That's how fast it was going. That's how fast the x was changing. So that 100 feet per second, we can just pop that on in there, and we can say that's our dz dt, or our dx dt. My bad. Our dx dt is just going to be 100. Now we need to go find that x. And that x is saying it was halfway down the third base line. Isn't half of 90? Isn't half of 90? So our when, that thing we've been waiting on, that when was actually 45 feet, halfway down. So we can pop in our 45. Now we're still left with having to find z, because that z would be changing. Now I'm going to show you how to do this without a calculator. Now there's other ways of doing this just with basic trigonometry, recognizing something about this, that our x is half as long as our y. It's half as long as our y. We could use a little bit of calculus. We'll probably end up with like a root 3, or calculus, trigonometry. You probably notice we'll end up with a root 3 somewhere. But what the hell, let's just go solve for this thing. We can do this. So what do we got? Our x value is equal to 45. Our y value is equal to 90, and we're trying to go find our z value. Yeah, there's our triangle. We'll draw it out again. Take it out of the diamond. Say 45, 90, and we just have to go find z. Root 3 times something. Whatever. Whatever. It must be crazy. All right, so let's run through and do this. So we're going to say it's, we take our first number, it's that 45, and then we're going to square all this stuff up, right? 45 squared plus 90 squared is equal to our z squared. We want to go solve for this. Now I want an exact answer. I don't want any of this BS. Here's some number out of a freaking calculator. I like to see an exact answer out of this. So we're going to write this a little bit differently. 45 squared plus, I'm going to write 90 differently. It's 2 times 45, right? We know that. We know that. So let's change this. We have 45 squared plus 4 times 45 squared. So we have 145 squared plus 4 45 squares. Isn't that going to be 5 45 squared is equal to z squared? Now let's hit this thing with a square root and see what pops out. And we don't have to worry about a plus or a minus. We're thinking everything's positive right now. So we have the square root of 5 times the square root of 45 squared is equal to z. Think anybody's got the square root of 45 squared? Of course you do. That's 45. So our answer ends up being 45 root 5 is equal to z. Now we just need to make sure we put our proper units in there, and we're saying that's feet, right? That was our feet. Oh, we don't need the units yet. We just need to pop this sucker right back in here. Right into there. So we get 45 over root 5. We look up top, we're like the 45 just cancel out. And we're going to find out that our dz over dt, the change in our z with respect to time, is going to be 100 over root 5. And it kind of cleans up pretty nicely here to rationalize this denominator. So I'm going to go ahead and do that. Give it a root 5 and a root 5. That's going to end up giving us what here? We're going to get a 5 in the bottom, and we get 100 times root 5. And we know 100 divided by 5 is equal to 20. So we get 20 times root 5. We look back at our units for our solution. It's feet per second, right? That's what we were dealing with. So it was 20 times root 5 feet per second.